Hello guys, you're welcome back to the reaction zone. In today's lesson, we're going to look at the electrolysis of aqueous copper sulphate using copper electrodes. Now, in this particular type of electrolysis, the cathode is made of pure copper and the anode is made of impure copper. The ions in solution are copper 2 ions, hydrogen ions, sulfate ions, and hydroxide ions. At the cathode, both hydrogen ions and copper 2 ions are attracted. However, copper 2 ions are preferentially discharged at the cathode. And this is because copper 2 ions are lower than hydrogen ions in the electrochemical series. So what happens is that copper 2 ions will undergo reduction, accepting electrons to give copper atom. At the anode, that is made of impure copper, neither the sulfate ions nor the hydroxide ions will undergo oxidation. Instead, what happens is that the copper atoms of the impure copper will ionize and go into the solution as copper 2 ions. So, copper atoms from the anode will ionize and go into the electrolytic solution as Cu2+. So what this means is that it is the copper atoms on the anode that will undergo oxidation. So in essence, when these copper atoms at the anode go into the solution as Cu2+, they will now go to the cathode and be deposited as copper. So what is essentially going on here is that copper is being transferred from the anode to the cathode. Now, the electrolysis of aqueous copper sulphate using copper electrodes is a key industrial application, and it is actually used in the purification of impure copper. In this particular electrolytic process, the concentration of copper 2 ions in the electrolytic solution usually remains roughly the same. It doesn't change, and that's because copper atoms are being transferred from the anode to the cathode. So I want to believe that this process is clear. Thank you very much for watching, and see you in the next lesson.